Hello everyone, today I will present my final hands-on project on responsible AI and explainability using the home credit deferral risk data. The goal of this project is to predict whether a loan applicant will default on repayment with target equals 1 means default target equals to thorough payments since credit decisions are high stakes. I focus on not only on model performance, but also on fairness, transparency, interpretability, and accountability. The dataset contains applicant level information such as demographics, employment, income, loan amount, and external credit scores. One important challenge is that the dataset is highly imbalanced with many more non-default cases and default cases. Because of this, accuracy alone is not enough, so I use ROC and AUC as a main evaluation metric and also report PR, AUC, precision, recall, and F1 score. For the pre-processing, I removed the ambiguous gender category X and A and treated the abnormal value 3 fixed 5243 in days employed as missing. I also created several interpretable features such as age, years employed, credit income ratio, and annuity income ratio. Then I dropped columns with very high messagings, impute missing values, and applied one high encoding to categorical variables. After pre-processing, I train a random forest classifier inside a pipeline so that the whole process remain constant and reproducible. In terms of performance, the module achieved a validation ROCAUC of 0.6575 and a PRAUC of 0.1745. The accuracy was 0.8815, precision was 0.2105, recall was 0.1702, the F1 score was 01882. I also used fivefold cross-validation. The average ROCAUC was 68968 with a standard deviation of 0.0328. This result showed that the model has moderate predictive power, but also that there is still room for improvement, especially in recall evaluate fairness. I use a gender as a sensitive feature and measure the demographic, demographic party difference, and equalized odds difference. The demographic party difference was 0.0174, which is relatively small. However, the equalized odds difference was 0.1491, which suggests that model errors are distributed differently across gender groups. When I look at the group level matrix, female applicants had higher precision and recall than the male applicants, while male applicants has a higher false negative rate. This means the model was less effectively at identifying true default cases for males, which is an improvement fairness concerns. For interpretability, I use SHAP, LIME, and PDP with ICE plots. SHAP provided a global explanation of which features were most important overall. LIME explained one individual prediction and showed which feature pushed the decision toward higher or lower default risk. PDP and ICE Plus have visualized how features such as EXT sources to AMT credit and age years influence the model's predictions. In particular, EXT sources to show a clearly negative relationship with the default risk with intuitive because a higher external credit score should correspond to lower risk. I also include a sample counterfactual style example. For one applicant, original predicted default probability was 0.381 after increasing income by 20% and reproducing both credit amount and annuity by 10%. The predicted default probability decreased to 0.3824. Although the changes were small, it shows how the models can support actionable what-if analysis. From an ethical perspective, this problem is important because both types of errors matters. A false positive may unfairly deny credit to someone who will repay, while a false negative may approve a risky applicant and increase lender loss. For this reason, I don't think the model should be used as a fully automated decision maker. Instead, it should support human judgment, especially in borderline cases. Finally, I considered the production readiness. I highlight the need for data quality checks, monitoring for drifts, regular fairness audits, threshold tuning, human review, and documentation such as modeling card and a bias report. These steps are important if the model is ever used in real lending improved environment. To conclude, this project shows that machine learning in credit risk should not be judged only by prediction accuracy. My model achieved responsible performance, but more importantly, it revealed fairness difference across gender groups and demonstrated how SHAP, LME, PDP, ICE, and counterfactual analysis can improve transparency and accountability. Overall, this project reflects the idea that a good model should not only work but also work in a fair, explainable way. Thank you.